Hello everyone. In this video, we are going to understand Python modules. A Python program is made using three different components. First one is library or packages, second module, and third functions and submodules. Understand about Python libraries, modules, and packages. A module is a file containing Python definitions, functions, variables, classes, and statements. And the extension of this file is .py. In 11th class, we make so many programs. Every program is saved with an extension .py. The name part is we give the name of that program and we put a .py extension with that program. Then we put all that programs in a particular folder. Once we make a program, we are save it .py extension and then we put that program in a particular folder. So module is just same of that program. That module also say that a module is a file containing Python definition, functions, variable, classes and statements and the extension of .py. In this we make use of variables in class 11th, statements of Python and the file extension .py. These three things we are already used in class 11 and put all that programs in a particular folder, and that particular folder is known as Python package. Then library. A library is a collection of many packages in Python. Now understand step by step. First we make a program, then we save it .py extension, then we put that program in any particular folder and this particular folder is known as packages and collection of that folders is known as library in the Python. Generally there is no difference between Python packages and Python libraries. Module in Python. As we know, module is a file containing Python definition, function, variable, class, and statement, and the extension of this file is .py. Now, the name of a module is the name of .py file. Example, in math.py, the module name is math. It means if we write a program, then we are going to save and whatever name we are given to that file is become the name of that module, and underscore name underscore variable is used to store this variable. Now what are the advantage of using module? If we write any program and save it as a module, then in any another program if you want this same functionality, then we can directly call that module in that correct program. It means if we write a code once, we can reuse it many times. But it means we don't have to write a same code again and again. We have to write a code once, then we can use it so many times. And by this program make much more logical and appropriate. Now, how to include module in our current program? If module is already made, then we can include that module in our current program just writing a simple statement import, then space, then the name of the module, import space and name of the module, then that particular module and its whole functionality will include in our current program. Now if we don't want to include all the functionality of that module, suppose if a module have 10 functionality, if we include that module, the whole 10 functionality is included in our program by import space module name statement. But if we don't want to all that functionality, suppose if a module have 10 functionality. And if we want all 10, then we have to write import space module name. That's it. All the 10 functionality is included in our current program. But if we don't want to include all the 10 functionality, if we want to include only one or two functionality of that module, then we have to write from space, then module name, then import, then the object's name. It means the function's name. If we want to only two functions, two functionality of that module, then we have to write from module name, import functionality 1 comma functionality 2. Then only two functionality out of 10 will include in your current program. How to make module in Python? As we already know, if we make a program, then save this program with .py extension. In this example, I take a name shape.py. First, I make a function, different function to calculate area, and then save this file shape.py. .py is compulsory to make a module and save it in the same folder. Now this I define three functions: area of circle, area of rectangle, and area of cylinder, and save with .py extension. It means it become a module. Now any other program, if I want to include this module, I just write import shape, because shape is the name of my module. Import shape, then it import shape module in current program. It means all the functionality of shape module now is included in our program, so we can directly use its functionality. It means we can directly calculate area of circle, area of rectangle, area of cylinder. And now if we don't want all the functionality of shape module, if we want only shape, area of circle, or area of rectangle, or area of cylinder, we don't need all these three functionality of that module. If we need only one functionality of that module, then we write from shape import area circle. It means now we are fetching only one facility from that module. If we write import shape, then all the facilities of shape module will include in our current program. And if we want only one or two facility of that program, then we have to write from shape import, then the functionality name. Namespace in Python. When we import a module in our program, which was referred as a namespace. Namespace is used to separate the different section of a program. Python has three types of namespace: global, local, and built-in. This is just like variable scope in Python. When we start interpret, then a namespace is created in which print and id etc. already exist. This holds all the built-in names. Each module creates its own global namespace. When we call a function, then a local Python namespace is created where all the name of functions are exist. In previous video, we understand the scope of a variable. A scope of a variable, it means a variable has a scope of two types, local and global. Same with the namespace. The namespace created by module is a global, and namespace created by our function is local. Now suppose we include some modules in our program, and this module come with their own functionality, their own variables name, their own function name, and in our program we are also write some variable name, function name, etc. Now it may be a conflict between our variable name and the module variable name. In some case it will be the same name as we are given and that are already in module. Then compiler will get confused which variable you are asking for. Then there is a rule for resolving the scope of a name. For every name reference, Python always follow name resolution rule when you access variable from any program or function. This is known as LEGB rule. Following work are done when this rule is followed. First variable is checked in local environment, and if it is available then it will be used. We already learned about local and global environment in previous videos. Second, if variable is not found in local environment, then compiler will check in enclosing environment, and if it is available then it will be used. Now if it not available in enclosing environment, then the variable is searched in global environment, and if it is available then it is used, and if it is not available then the variable is checked in built-in environment, and if it is available then it will be used, and if it is not available there also, then Python will generate an error. It means first the compiler search in local environment. If he found, it will use. If he not found in local environment, then transfer to enclosing environment, then global environment, at last built-in environment. Packages or library. Python packages is the collection of same type of module, as we already discussed. You can use built-in packages as well as your own packages. Python package is a simple directory or folder. Modules are stored in that directory. Package or library are generally same. Step to make a package: we create a folder or directory named geometry, which will contain two files, area.py and volume.py. In the same directory, we will put another file name underscore init underscore .py. Underscore init underscore .py isn't necessary because this is the file which tells Python that directory is package, and this file initializes the package. Then we import the package and use of that. This is an example how we make an package. This is the folder in which will be our package. In this underscore init underscore .py file, which is made directly by saving from Python IDLE. These are the modules which are the member of the packages. Now we write the line from geometry import area, comma, volume. So from geometry module or package, these two files, area and volume, will include in that current program. Now how compiler locate the module? When we import a module, then interpreter of Python search the module in the following sequence. First, in current directory. Second, if module not found, then it will be searched in shell variable Python PAT. If not found anywhere, then Python search in default. Default path is the Python where Python is installed. Now make two modules on factorial program and Fibonacci series program. First, make factorial program with function, and in the same program you have to write another function for Fibonacci series function and save this program with .py extension in a folder. In that same folder, create a file underscore init underscore .py file, so it become a module and a package. Thank you.